So for chapter 9, it is about the symmetry and transformation. And now we are going to discuss the first part, that is the symmetry. And first of all, what is the meaning of symmetry? Then let's look at this slides. And you can see that the definition of symmetry here, when a plane figure is flowed along a straight line, and then the two sides of the figure coincide completely. And the meaning of coincide, that means they are overlapped. 咁中文我哋即係話其實佢係重疊咗、重合係嘛？重合咗嘅意思。And then this figure we call it as reflectional symmetry. So you can look at the following example here. When the line, you can see the blue line here. If we draw a blue line here, and if we fold along this blue line, you can see that the two sides are coincide completely. And for the second figure, also look at the blue line here. Then the two sides, can you see that the two sides here also coincide? And for the last figure, you can see that the blue line also cut the figure into two parts. Now it is the upper part and the lower part, and they are coincide if you flow along the blue line. And that's why for this blue lines shown in the figure, we call it as the axis of symmetry, or sometimes we may call it as line of symmetry. And next, let's look at further some more examples. Now, for these two figures, you can see that actually there may be more than one axis of symmetry. And when you look at the first figure, it's like a letter H. And we can draw the axis of symmetry here, that means the green line. And this is one of the axes of symmetry. Also, you can see that if I draw a vertical line here, I can get another axis of symmetry. So for this figure, there are two axes of symmetry. And for the second figure here, actually, there are four, because we can draw in this way. That's why there are four axes of symmetry. And then you can look at some more example here. For example 1, determine whether the figures below have reflectional symmetry. If so, that means if yes, then draw all the axes of symmetry. And then for this, I think you can try to draw it, and then you can check the answer. Actually, the answer is shown in the next slide, and I don't want to discuss any more about the answer here because I think you can draw it easily. Just try to draw the line, and then this line can make the figure to fold along this line, and then you can get two sides coincide completely. So for different figures, for example, for figure A, that means the letter M, only one axis of symmetry. And for figure B, there are two. And then for figure 3, that means part C, there are 1, 2, 3, 4, 5. Totally, there are 5 axes of symmetry. And the next example is more complicated because for this is an open-ended question. And for this, two isosceles right-angled triangle are given here. Then you need to try to form a figure that have reflectional symmetry. And why it is open-ended? Because actually there are many solutions. That means different form of the figures can have reflectional symmetry. But you just need to form two figures. And then if we look at the solutions here, you can see that I can form the figure like this. Then you can see that actually the axis of symmetry is here. So you can see that the two sides are the same. That means if I throw along this axis of symmetry, the two sides coincide completely. Or this is the second solution. You can see that for the second solution, I can draw the axis of symmetry here. Then you can see that these two parts are coincide completely when we are folding along this red line. That means the axis of symmetry. Or you may say that actually the axis of symmetry can be another line segment. For example, some of you may say that it may be this line, also the axis of symmetry, or this line, also the axis of symmetry, or this line. Actually, there are 4 axes of symmetry, but I don't care about that how many axes of symmetry here. I just can form the figure to have reflectional symmetry. So these 2 are the possible answers. But can you see that on the right hand side here, there are another 2 more reasonable, or I may say that that is the acceptable answer here. So that's why this is the open-ended question. That means more than one solution, okay, just to form the figure that have reflectional symmetry and just in any possible way. So this is the open-ended question. And then this is for the reflectional symmetry. And the next about the symmetry is that we have another type of symmetry. We call it as rotational symmetry. Rotational symmetry in Chinese， 咁我哋中文叫做一個咩呢？旋轉對稱。旋轉對稱，咁即係話我哋要轉佢嘅。Okay, 我哋要轉佢嘅。In rotational symmetry, we have to rotate the object. And then for here, the definition for rotational symmetry is that a plane figure which coincides with its original figure. That means the same as its original figure more than once. Okay, should be more than once. Then it is rotated through one complete revolution. One complete revolution, that means one round. One round, that means 360 degrees about a fixed point. Okay, about a fixed point. Then it is said to have rotational symmetry. So let's look at some examples about rotational symmetry. You can see that for this figure, this is a rectangle. And we may say this is the fixed point because we always need to rotate the figure. And I don't care about it is rotate in the clockwise direction or anti-clockwise direction, but you have to find a fixed point and then rotate about this point. In the rotation, for example, in this figure, I just mark a yellow dot here. Just mark a yellow dot here to remind us that it turned for one round. That means 360 degrees only, okay, for this dot, just a reminder for us. Then you can see that in the PowerPoint when we rotate, okay, after the rotation of 180 degrees, I find that, can you see that this figure is exactly the same as this figure? That means coincide with its original figure. Okay, that means this figure appears once after rotate for 180 degrees. And then you should further to rotate the figure because until 360 degrees. Then further 180 degrees, that means go back to the original position. Of course, this is the same figure as this. So the same figure appear twice. That means 2 times. And then we will call it is the rotational symmetry. And for the fixed point here, we call it as center of rotation, the fixed point. That means this point. We call it as the center of rotation. And for this, we rotate it And then for the rotation, and then we look at some more, okay, some more example in the next slide. You can see that for the other figures, then we should count how many times of the same figure, okay, the original figure appear for n times. We should count how many times of the original figure appear in one revolution. That means one round, 360 degrees. And then we should count the number of times that is called as the n-fold rotational symmetry, or we may call it of order n. And then the order of rotational symmetry is n. So let's look at the first figure here. For this figure, you can count in complete revolution, in one complete revolution, 360 degrees. When you are rotating it, then you will get one time, okay, the yellow dot moves here, and then appear once of the original figure, and then go back to the original. Can you see that the yellow dots here, further 180 degrees rotation. Then you will get two times of the same figure, same as the original figure. And that's why we call it as the two-fold rotational symmetry. And then for the second figure, I just marked the yellow dot here to remind us that here is the original position. And then when you turn the yellow dot up to here, then the same figure appear once. And then when the yellow dot come to here, the same figure appear twice, and then go back to the original position. That's why the same figure as the original figure appear 3 times. Then we call it as three-fold rotational symmetry. And the same idea for the third and the fourth figure. You can see that for the third one, when you turn to here once and then twice, and then the third time, lastly the fourth time. That's why this is the four-fold rotational symmetry. And next, for this, when the yellow dot marked here, and then when you turn, to rotate up to here, the same figure appear once, and then 2 times, 3 times, 4 times, lastly 5 times. That's why here is the 5-fold rotational symmetry. So this is the idea about the rotational symmetry. And then for this is another example. For example 3, you have to identify where is the center of rotation. And then you also need to write down the order of rotational symmetry. And I think it's very easy to mark the center of rotation, and we always use a cross to mark it. And then for all of the figures, it's very easy to mark it. Mark cross here, mark cross here. This is the center of rotation, the center point of the figure. It's very easy to mark it. This is the task for part A. And then for part B, you have to write down only. That means no need to explain and no need to do the turning to show me that how you can get the answer. Just write down the answer. That means the number of the order of rotational symmetry. And for this figure, and then when you rotate for 180 degrees, I think that means up to here, then you get the same figure. And then go back to the original one. Then the number, the order of rotational symmetry, it should be 2. And then for this figure, also easy to do it. When you look at the figure, like here, and then, for example, you also may mark a dot here. When you rotate, when you rotate the figure up to here, the dot may come to here, and then further come to here. So lastly, I think you can have 3 times of the same figure, as the original figure, in the turning of 360 degrees. That's why the order is 3. And then for this, I think it's not difficult for you to find out the order is 4, 5, and 6. Okay? So it's not difficult to find this and to identify what is the order of rotational symmetry. So you can look at the solution here. I don't want to repeat any more about this. I think it's the easy idea about the rotational symmetry. And then let's look at the next example. And for this example, also do the same, that you have to identify the figure that have refractional symmetry. Then for the refractional symmetry, that means if you draw a line, that means the axis of symmetry, when you're folding along the axis of symmetry, the two sides are coincide completely. Then let's look at figure A, part A. I think you can draw the axis of symmetry easily. For example, here, then this, figure A, part A, this figure have refractional symmetry. So the question is that, ask you to identify, that means you have to claim that figure A has refractional symmetry. And then the second task is to draw the axis of symmetry. You have to draw it and mention that figure A has refractional symmetry. And then for part B, I think there are no refractional symmetry here, right? And then for part C, there are refractional symmetry. Then you have to draw the axis of symmetry. And there are 5. 1, and then 2, 3, 4, and lastly 5 here. Then you can draw the axis of symmetry. And then you can finish part A, part 1. And then part 2, another drop is that you have to identify the figure that have rotational symmetry. And also use the clause to indicate the center of rotation. And for this part, also easy. So I just want you to look at the solution here. So can you see that we have to state that there is refractional symmetry, but no rotational symmetry. And then just need to draw the axis of symmetry here. And for part B, there are no there are no refractional symmetry, only have rotational symmetry. That's why you have to draw the clause here for the center of rotation. And some more information is given that the order of rotational symmetry is 2 for part B. And lastly, for part C, I only did part 1 now. That means I only draw the refractional symmetry, the axis of symmetry here. And also for this figure, there are rotational symmetry as well. So we also need to mark a clause. This is the center of rotation. So for part C, it has refractional symmetry and rotational symmetry. And some more information is given that there are 5 axes of symmetry, and the order of rotational symmetry is 5 as well. And then lastly, I would like you to look at some more special case. But actually for this special case, it's easy to understand for the regular polygons. But I think some of you forgot what is the meaning of regular polygons. Do you remember we discussed this before? In first term in book 1A. When all sides are equal and all interior angles are equal, then we call it as regular polygons. So for example, you can look at the figure A, B, C, and D. You just need to count the number of sides of the figure, which is 3, 4, 6, and 8. Then it's very easy to remember that how to count the number of axes of symmetry. It is equal to the number of sides. Also, what is the order of rotational symmetry? Also the same as the number of sides. Also 3, 4, 6, and 8. I think it's easy to remember for the regular polygons. So there are some special cases here. Just want to remind you about some special case. For example, the regular polygons. Just need to count the number of sides. Then we know the number of axes of symmetry and the order of rotational symmetry. That's why this is the conclusion about the regular polygon. A regular n-sided polygon has n axes of symmetry and n-fold rotational symmetry. So I think for the symmetry part, it's not difficult. And I hope that you can try the lesson worksheet as well for the symmetry part. That means the exercise 9A. So for exercise 9A, I want you to look at the lesson worksheet as well. And for this assignment, I think you better to print out the lesson worksheet, or if you have the math book, just do all the exercise on the math book, because actually you need to draw quite a lot in this exercise. And then I think it's more convenient for you to just do it on your math book, and then just take a photo of the math book and upload your homework in Google Classroom. So for this, I just want to try some of the example and just want to remind you about some points in this lesson worksheet. You can see that for the drill, I don't want to discuss anymore about the drill. I think you can refer to the example here and then just follow the presentation as the example. Then you can do the drill 1 easily. And I just want to remind you that about this for question 1, can you see that you have different job for different questions. For example, question 1, you have to state the number of axes. Okay, can see that you have to state the number of axes here. And then for each of the following figures that have reflectional symmetry. That means for the figure, if there are reflectional symmetry, you have to state the number of axes. And the next task is that you have to draw all axes of symmetry. That's why here you have 2 jobs. Okay, that's why here you have 2 jobs. First, state the number of axes of symmetry, and next, draw all the axes of symmetry. For example, for the first figure, can you see that this figure? Then you have to state what is the number of axes of symmetry. I think for this, you may simply just to write down the number 1 here. And then you have to draw all the axes of symmetry, because for here, you have to write down the number 1. And then next is that to draw the axis of symmetry here. I may use the dotted line. Sorry. For this one, there's an arrow here, but it doesn't matter. Okay, you can see that 2 jobs. First of all, write down the number of axes of symmetry, and next, draw the axis of symmetry. And then for part B, the same, that if you look at the figure, I think you can easily to draw the axis of symmetry here, 1, and next the horizontal line here. And then we always use the dotted line to mark the axis of symmetry. And then I think no more axis of symmetry. Then you may also write down the number of axis of symmetry, that is 2. And then for part C, D, E, and F, do it by yourself. Just follow this. I just want to remind you that for question 1, you have to state the number of axes of symmetry and draw all the axes of symmetry. And then for the second part, it's about the rotational symmetry here. Also, for the drill 2, I think you can refer to the example 2 to do it. I don't want to repeat about this, just follow the presentation about example 2. And then for question 2, you can see that each of the following figures has rotational symmetry. Then you have 2 jobs as well. First of all, use the cross to mark the center of rotation. Also, that means the second job, state the order of rotational symmetry. Then for the first figure here, part 2, question 2, part A. First of all, I think you can mark the cross here. This is the center of rotation. And then what is the order? The order should be 2. Okay? Because when in one complete revolution, that means when you turn this figure for 360 degrees, the same figure as the original figure appears 2 times. That means the order, you have to state the order of rotational symmetry, that is 2. Then you may just write down the number 2 here. And then for part B, do the same. Mark cross here. I think the cross should be here. And then when you rotate this figure, the order of rotational symmetry, it should be 3. Just like this to do it. And then I think you can try the rest. Okay? And then for the next part, I think you can do it by yourself. And I just want to discuss the last question. Question 5. Let's look at question 5 and 6 here. I may try part A with you, and then you can try part B by yourself. Now, for this question, in each of the following figure, look at question 5. Shape 1 square only, so that the dotted line becomes the axis of symmetry of the figure. Just need to shape 1 square. You can see that in the figure, there are 1, 2, 3, 4, 5. 5 squares are shaded. Then shade 1 more only. And then I think it's not difficult for you to shade the square. This square only. Then you can find the answer. And this dotted line will be the axis of symmetry. And then try part B as well. Remember to shade 1 square only. And then for question 6, you can see that for question 6, in each of the following figures, shade 2 squares, so that the course becomes the center of rotation of the figure. Now you have to shade 2 squares in question 6, not only 1. Then for question 6, I think it's not difficult for you to shade this square and this square. Okay? So after you shade these 2 squares, you can find that here the cross is the center of the rotation to make this figure have rotational symmetry. And for part B, try yourself, okay? Try your best to finish this. Remember, you have to shade 2 squares for question 6, part B. So try your best to finish this exercise and upload in the Google Classroom. And just remind you that try your best to draw all beautiful, okay? Draw the nice figure and then upload in the Google Classroom, okay?